All right, hi everyone. So let me share my screen first. You guys able to see my screen?
Yes.
Yes, clear.
Okay. So first, I would like to welcome everyone from different departments from attending today's meeting. We welcome the representative from the construction, the environmental, the finance, and the engineering department. So today we are going to discuss about our upcoming project from Midsummer University. So this time, our client is the Midsummer University, and the project is we want to construct a postgraduate campus in Hong Kong. And then they have a project budget of 300 million Hong Kong dollar. So I guess we already know this information, and our department have carried out our discussion respectively, and we have ready the material for today's, right? So let me recap. The project, we need to support the population of 50 students and 22 research scientists. And then we need to provide accommodation to the 50 students. And they require the campus to be self-sustained in energy production and consumption. So we need to come out with the energy generation facilities on the campus site. And they also wish to minimum the impact to the nearby environment. So we need to carefully consider our construction and the choice of energy generation. And lastly, they want to achieve a saving of energy costs in the long term because they want to self-sustain the energy. So they expect to consume no or minimum energy from the electricity grid. So this is the main project scope. And now we are going to start our meeting. First, let's start with the general floor plan of the campus. So Fazil, are you ready?
Yes.
Yeah.
I will start sharing my screen. So good afternoon to Kayang and Peng Yang. So I will start with explaining on the floor plan of the postgraduate school in Hong Kong. So the requirement for this
the video haven't load.
Okay.
Oh, okay, it's load now.
Okay, good afternoon to Kayang and Peng Yang. I'll be explaining the floor plan of the facilities in the postgraduate school in Hong Kong. So the requirements of the project is to cater for the research facilities of 50 postgraduate students and 22 researchers with accommodation for 50 students. So we start with the accommodation building. So as you can see here, this building consists of 3 stories of the same floor plan. So we have provided a 6 single room and also 6 double room for each floor. And the total number of occupants for each floor will come to 18. And the total number of occupants for the whole building will be up to 54, which is we cater for 4 extra students. And then we also provide the common room, which can occupy up to 13 students at one time, and the kitchen, which can provide the required facilities for cooking for 6 students at one time. So total of number of occupants for the accommodation building, it goes up to 54 students. And then we move on to the general building, which consists of the bank, convenience store, and also the canteen. So the canteen, the requirement for the canteen is to cater up to 50 students with extra number of seating for a special occasion. But we only have 1 floor for the canteen, which can occupy 80 students, which have exceeded by 8 number of, sorry, not student, 80 occupants, which have exceeded by 8 occupants as required by the project. Next is the laboratory building, which have 4 stories of the same plan. So here we provide 6 office rooms for the researchers, and also 3 main laboratory buildings, which are the physics, biology, and also chemistry. And each laboratory can occupy 8 members or 8 researchers at one time. So the total number of researchers that can occupy the office room goes up to 24. And for the laboratory, the total number of researchers for the whole building can go up to 96. Okay. And next is the last building will be the lecture building. The first floor consists of the IT suite, which can occupy 10 researchers at one time. And behind here, we have the library. And next, we have two main lecture halls. Each can occupy up to 50 students and one presenter. And lastly is the seminar room, which is the topmost floor, which can occupy up to 30 students at one time. Okay. So this is the arrangement of all the four buildings. We put the accommodation and general building close together, and then this is the main road we should cross by the whole campus. And here we have the laboratory building, and opposite it the lecture hall. Okay, and all buildings are connected by walkways because they are within the walking distance, and there will be one main road crossing through the whole campus, and we keep the biodiversity of the site intact. As we can see here, we do minimal land clearing for the campus. That's all from me. Do you have any question?
No, for me so far. It's okay.
Okay. I'll start sharing my screen.
From Yang, any question?
No.
All right, so we can move on to the next part about the energy production. I will continue with that part. So let me share my screen. Okay, so when you guys can see the screen, just tell me. Yeah.
Yes.
All right. Okay. So about the energy production, our main requirement for the project is we need to let the campus self-sustain in energy and have a low impact to the nearby environment. So before I go on to the design of the energy production system, let's see about the energy consumption of the campus first. So our client has provided us with the energy consumption of the facility of their main campus and their historical consumption. So based on the facility list that provided by Fazlil, I have estimated the total energy consumption for the campus. So basically, we know the each unit of the facility, and we know the area of the facility when we don't have the unit available. So we have the data from client. What I do is I use the unit to multiply with the unit consumption of the facility to get the energy consumption. Same goes with the area of the facility. So after this calculation, what I get is the campus will consume about 210,000 kilowatt hours per year, equivalent to about 580 kilowatt hours per day. So with this energy consumption, we can go on with the design of our energy system. And our client has provided with us about the technology they suggested, which is solar, wind, biomass, radioisotope thermoelectric, and also geothermal. So after our department discussed about that, we would like to suggest to use solar energy as our technology that used in our campus, because we analyze their pros and cons based on the environmental impact. And there are mainly four factors we are looking about. It is the emission during operation, whether there are waste generated during the operation, whether there are noise pollution during the operation, and whether the technology require additional land clearance. So emission during operation, actually quite a lot of renewable energy pass this criteria, only with biomass as exception. So we already exclude biomass as our consideration because we need to put the energy generation facility on site, and the emission will just affect the health of the student and the research scientists on site. About the waste generation, biomass and radioisotope has waste, other is okay. And one important factor is the noise pollution, because the scientists and the students need to study and conduct research on site, so we don't want any noise pollution. The only two tech that pass this criteria is the solar and the radioisotope thermoelectric. But then the last factor, because our client need to have a low environmental impact, right? So the only one that passes this criteria is the solar, because the solar can be installed on the rooftop, but others cannot. Others require additional land clearance for that. So our department would like to suggest we use solar for the technology we use on the campus. Is everyone okay with that, or has any question?
So far, no question. I'm okay.
I think due to the Hong Kong has the lot of rain season from May to September.
Yep.
If there's no sunlight, how to deal with these things? Yeah, I mean.
That's a good question. So our department has already ready some simulation report. Later we will mention about this too. So as a summary for now, the simulation report did reflect about the windy season, the rainy season, and the energy production is actually sufficient to support the campus. Later we will talk about it in detail. Is it okay?
Okay.
All right. Okay, so the decision for now is we will use solar energy as the choice of energy production. I will go on next. Yeah, so now that we decide about the solar as the main energy technology, I have some question I need to ask Fazil about. So just now when you show the site map, I want to ask whether the site orientation is already decided. Like for example, like what I mean is the site orientation fixed? Like, is it aligned to the north-south direction, or is whether it has some rotation? You see the screen, right? What I mean?
Yes.
Yeah.
Actually, we haven't decided on the orientation of the site yet.
Oh, great. So if I suggested some orientation, is it will cause any trouble, or is it okay to change to any orientation?
It's okay, yes.
Okay.
It's okay too, yes.
And about the roof angle, so what will be the roof angle we use for the campus right now? And can we change it?
Okay, that also we haven't decided on that. Yes.
Okay, then that's great. I asked that because to optimize the solar energy generation, I have some suggestion about the campus orientation and also the roof tilt. Let me briefly explain it. So basically, if we want to choose solar as the energy generation technology, the orientation of the panel is actually quite important for the energy production. Like there are mainly two things we need to consider. The first thing is how the panel is rotated. Like I mean, for example, the thing here is called azimuth. That is how rotated the solar panel is reference to the north-south line. And the second one is how steep the panel is arranged. Basically, the angle of the solar panel. The thing we need to do is to orient the optimum angle based on the site location. Yeah. So a general rule of thumb is like, for example, the site latitude. In our case, the site latitude is about 22 degree. So our tilt will need to also arrange it into 22 degree. So if you are okay with the, maybe I suggest to leave the roof flat so we can set up some rack to tilt the solar panel. And another suggestion is to make the whole campus align to the north-south line. Basically making the azimuth to the 0 degree. You're okay with that, right? Later I can explain with you in details.
Yes, I think I agree with this, and this is such a brilliant thing to consider when we are deciding on the buildings.
Okay, right. So based on that, yeah. So the rough design for now is our solar system will follow the north-south line, and the panel will be arranged in the 22-degree tilt. So our department actually have conducted a simulation report based on that, and this one will also address Feng Yang question just now. So based on the simulation report we done, so you can see I have two report ready. One is in the optimum angle, another one is just an example angle of a non-optimum arrangement. So the first one is the panel we arrange in a 30-degree tilt and 70 degree away from the north-south line. And the second report is the optimum angle. The 22-degree tilt is follow the site geographical location, the latitude, and the azimuth is 0, follow the north-south line. So the result we can see here is when we arrange in a not so optimum, you guys see the bottom left graph, that is basically the energy use of the solar system. So when we arrange in a not so optimum angle, see the use here compared to the optimum one, the optimum one will have a higher generation. So basically based on our report, after the optimization, we are able to generate a monthly generation of 17,000 kilowatt hours more. So it is basically equivalent to 4 months worth of the campus energy consumption. Yeah, so the final system I would like to suggest is, yeah, basically is in this optimum orientation. And after I done the simulation report, what I estimate the energy production for our system will be a yearly production about 1 million kilowatt hours. And the campus annual consumption is only 210 kilowatt hours per year. So it is more than enough to support the campus consumption. So the graph here, you can see that the pale blue color is our solar system output, and the dark blue one is the campus consumption. So the system will have no problem to support the campus consumption even after 30 years. And the slope of the graph is because of the degradation of the system, which our department take it as 0.6%. That is, according to the data sheet of the equipment we use, it is a 0.6% annual degradation. Yeah. So about Feng Yang, just now, your question. The windy seasons and the rainy season did reflected on this graph. So the minimum output is on March, and this we have done some calculation on this. Basically, we don't have to worry about this because even with the lowest output, we still have more than enough energy to support the campus consumption. So yeah. So I think that's it for my part. Is there any question for now?
No question from.
I think you know that if at the night there are no the middle light, like something that they are low lighting. Yeah, how does this solar system work?
Oh right. Sorry, I forgot to mention.
Support this system. Yeah.
Yes. Sorry about that. I forgot to mention about that. That is a totally valid point. Yeah. So the solar system won't work in the nighttime. So we also included a battery storage system for that. Basically for that, the battery capacity we plan is to able to sustain the campus consumption for 5 days. And the capacity of the battery will be about 3,000 kilowatt hour. We get the value because the capacity, the consumption of the campus daily is about 2009. So we just propose the battery capacity to be 3,000. So with this battery, the campus is able to sustain for 5 days without any charging. Yeah, sorry, I didn't mention about this important point just now. Right?
Oh, so we can, if there's no low lighting or low sunlight, we can still hold 5 days, right?
Yep. Yeah, based on the forecast, there's plenty of energy available.
I think that is a wonderful design for solar system. Yeah.
Yeah. Okay. Any more question on the energy generation part?
No question.
Okay, then I think we can move on to the next part, the financial analysis.
Okay. This is the whole budget for campus building. We can see that they are including all the facilities about accommodation and general building. We can easily see the whole cost may be the these values and the whole requirement for energy, maybe these values. Let's see this graph. Yeah, you can see that the peak value for capital consumption could be the land clearance. Yeah, maybe the Hong Kong is the prime pieces of real estate and also the world economic center. So land clearance is too expensive. And I also see the second value, second peak value to be the solar system. Yeah, so cause we have to bring some green energy and also cost saving. So we choose the solar system. And if we look at the energy consumption, we can see that the peak value could be the shear zone. Yeah, maybe you have to supply the enough room for nearly 50 students. And after that, we can see this one. Let's look at this photo, and you can see this is capital consumption, and this one is our requirement for campus building. This one is for the our budget for campus building. We can see that we have enough money after we finish this campus building, and we also have enough energy. We can see that this is the energy requirement per year if we want to support our whole campus system functioning well. And this is if we use the solar system, we could produce this energy. So this is means that we have enough energy. So we may make some sale or that to get to earn more money. Yeah. Also, so do you guys have any question about the budget? Yeah.
Yeah. So our client do give us some budget, but so do give us enough budget for this project, is it? I mean,
yeah.
They also need to try to achieve a saving as much as possible, right? So after we do the financial analysis, do you found any way to help the client to recover some costs?
Yeah, I have searched some of the information online. I have choose one of the I may choose some of the company as an example. Maybe the biggest company, electric company in Hong Kong. Yeah, they have the policy for feed-in tariff. Yeah, I will show you.
Okay.
Okay. Can you guys look at the feed-in tariff scheme?
Yep. Now we are looking at it.
Yeah. This is from the Hong Kong Electric Company, maybe the biggest company in Hong Kong that supplies the electricity for the residents. Yeah, we can see this is the price for saving electricity or energy. Because we have excess energy, we just build the solar system, so we can sell some electricity to this company. If we considering our capacity of solar system, so we could choose the $3. Yeah, the price is maybe choose the $3 for our calculation. Yeah, later I will show you the some of the calculations after this period. And
so our excess generated energy can sell back to the Hong Kong government, is it?
Yeah.
Okay,
This
right,
Hong Kong,
right.
we may, but I'm not sure still to the Hong Kong government or this Hong Kong electric company.
Oh, company.
Maybe we choose. Yeah. We may sell directly to this company. Yeah, maybe government may make some administration or something like that. Yeah.
Right. That's great.
Yeah. I will share another. Could you say the Excel? Okay. Can you see?
Oh yeah. For now, yes.
Okay. Sorry, I'm not familiar with this. Okay. Let us continue. Yes. Yeah. You can see this chart. We can see that this line for the cumulative margin from selling electricity. Yeah, before I told you that we choose the maybe the $3 for the calculation. Yeah.
Yeah.
And this line for the solar system cost. Yeah. This line for the total cost if we build this computer system. Yeah, you can see that we also we got make assumption about we make the system make this computer system work in a period of about 30 years. So maybe at the 8 years, we may earn back the solar system cost. Yeah, you can see this. Yeah, 8 year, and after nearly 29 years, we can earn back the whole cost for campus building. Yeah, so it's clear that if I need any more explanation, Kayang.
The solar system cost is already include both the solar and the battery, right?
Yeah.
And
you can see
yeah, and
yeah,
the
you can see this
total.
one. Yeah.
Okay.
This is the solar system cost. Already include the battery storage and the building for solar system. Yeah.
Yep. And the total project cost is all the construction cost plus the solar system cost, right?
Yeah. The whole cost is the all. Yeah.
Yeah. So they just need 29 years to get back all the investment.
We need we need around 29 years. We can earn back all the money we cost for this campus building. Yeah, but we just need 8 years for the solar system cost to earn back the money. Yeah. So I think solar system is worth us to building. Yeah.
Yeah, that's not bad. For 8 years to return all the investment for the energy system and 29 years for the whole campus, I think, yeah, that's good. We can propose this to the customer.
Yeah. So any question for guys?
No from me.
No from me.
How about Fazil? Okay.
No.
Okay, that's nice. So yeah, next we can go to the carbon emission analysis. Is Fazil part?
I'll start sharing my screen.
All right.
So after we have gone through with the budget analysis, so now we will look into the. Can you see my screen?
Yeah.
Okay. So now we will look into the carbon emission analysis to see the environmental impact of our project to the ecosystem. And for this, we will look into the solar energy life cycle assessment of different solar photovoltaic panels which have been reported previously in several literature and compare that to the carbon emission from the HK electric power grid in Hong Kong. So to brief through, solar energy LCA is a method developed to analyze the environmental impact produced by solar panel and its lifespan from the raw material procurement, manufacturing, and to its disposal will be taken into account to look for the carbon emissions generated. And for this, I have gone through two literature. The first one is a more recent one, and which is Milossi et al. And the second one is of 2016 by Wu et al. This first paper differentiates the carbon emission from the LCA of different types of solar PV type, which are the single crystalline silicon, multi-crystalline silicon, copper indium deselenide, and amorphous cells. These two are considered of the thin film, and this one are of the crystalline. And this second paper only compare on the multi-crystalline silicon cell of the solar PV from five multinational studies. So it only shows one type. But from this first paper, we can see that the CIS type produced the least amount of carbon as compared to all four. However, its efficiency level is not as great as the other two. which is about 8 to 11 as compared to the crystalline type, which is 11 to 18. And more so, we only have this MCSI compared with the second paper. So we have to take into consideration the carbon emission from MCSI from this study with that of the second. So this is about 33.4 to 44.3. And the first study has a slightly higher value than the second. Okay. However, the second study takes the value from 5 different reports, and the amount varied a lot. And from there, I calculated the standard deviation and found out it is to be very large, which is 18.97. So from here, I think we should look into the carbon emission from these more recent studies. And then, the second part is we have to compare the carbon emission from the LCA assessment with that produced by HK Power Grid in the year 2020, which is the more recent report. So I've gone through the sustainability report of this company and found out that they produce close to 710 gram carbon emission in a year, which is slightly above their average aim, which is 600 gram. Okay, and then taking these two value, before I proceed with the rest, I would like to ask from the engineering team, which of these types which will be considered for the building of the solar panels in the campus, according to the report?
Yeah. For now, what we pick for the design is we will use a multi-crystalline silicon.
Okay. All right. So I'll take this value from the MCSI multi-crystalline silicon and compare that with the carbon emitted by HK Grid. And here, in the 30 years period, you can see that there's a very large carbon emission offset from both. Okay, and this shows the cumulative carbon emission from the solar PV and also the HK electric power grid. Okay, so that's anything to ask?
No, for now. Great.
Okay,
Not yet.
that's all from my report on the carbon emission.
Okay, so let's see whether we achieve. Okay, I think we've gone through all the departments report. Yeah, so we have gone through all the department report, and now the project requirement of support the population, provide accommodation to the student, self-sustaining energy production, minimum impact to the nearby environment, and saving of energy costs in long term. Yeah, I think our planning so far has achieved all the project requirement. Yeah, I think that's good. So if there's nothing else to add on, I think we can proceed to prepare a report to our client, and then we can stop our meeting for today. Is there any question else? Anything else?
No.
Yeah.
No
No.
question.
All right, good. Then we can proceed with preparing the report. So I think that's all for our meeting today. And thank you, representative from the East Department, from attending today's meeting. Thank you.
Thank you. Thank you, Kang. Thank you, Fadil.
Okay, thank you.